Hi, everyone, and welcome to the MLOps podcast. I'm Dean, your host, and today I have with me none other than Jacopo Tagliabue. Jacopo is a director of AI at Coveo, which acquired his company Tuso, where he built search products. His role consists of doing research in the NLP field and sort of while exporting the learning to serve a huge network of customers. He is an adjunct professor at NYU, where he teaches about NLP and ML systems to graduate students. He has a PhD in cognitive sciences, and he's been working in the field of data science since 2009, working on varied problems all the way from data analysis for pro basketball teams to computational social sciences. And I think he is a leading voice in speaking about machine learning systems and MLOps, advocating for a term that he coined called Reasonable Scale MLOps. So, Jacopo, thanks for taking the time.
Thanks so much for having me. It's a pleasure and an honor to be here.
Awesome. So, let's start from the top. What does the term reasonable scale MLOps mean, and how did you arrive at this idea?
So we can start with the second for the birth of the concept, and that would explain the concept I hope very well. So when we started looking at what we as a field do and trying to kind of teach about this ML revolution and how to bring the incredible effect of ML to the wider audience, we realize there are kind of two type of content or guidelines you find online. The tutorial how to serve Scikit-learn with Flask, okay? There's like a million of that. And it serves a purpose. Like it goes from zero. I wouldn't say from 0 to 1. I'd say from 0 to 0.1. Okay, and that's fine. And then you get a lot of the stories from the people that build this platform at Uber or the other platform at Meta or the other platform at Amazon. And there's nothing in between for this thing, right? So there's people that are really, really starting their journey and they're doing very, very simple stuff. And there's nothing bad with that, but they're more similar to my students than to my colleagues and to my peers. And then there are people that work at humongous scale, which have completely different problem constraints, but also resources to solve these constraints. The reasonable scale evangelization, and we can discuss what it entails, but it's kind of the idea that there's a middle ground between the Flask tutorial and Uber serving infrastructure, and where is most people are. Because if you work at Uber, somebody else is gonna figure out the infrastructure for you. You just do your model. If you're starting up in the space, there's still a bit for you to go before you're realizing that you can ship your model to millions of people. But the people like me, the people that work at Tuso, my own company, or Coveo, the company that bought Tuso, are people that live in this middle ground, and they're the vast majority of practitioners. So there are either good tech companies like we are, but not with the resources that Amazon has, or gigantic companies, let's say Procter & Gamble or Louis Vuitton or whatever. There are successful companies in their own right, super successful, but they're very early in the MLOps journey. So their MLOps adoption looks more of like a startup inside a big company than a tech company per se. And it's this type of people that we want to address with the reasonable scale, artifacts, our repos, our articles, some of our papers. Is a giant number of people that are just outside the edge of the tail in big tech, but they still have a complex enough problem to make it interesting. Okay, so that's kind of, we started because we are a reasonable scale company. We started because my career in the last 5 years has been a reasonable scale career in some sense.
Yeah, that makes total sense. I remember when Guy and I got started with DagsHub, we noticed this thing as well. We weren't even thinking about this in the context of MLOps specifically, but there seems to be in all of tech like a bimodal distribution where you have a ton of content for like super beginners, like you don't know anything and you need to learn something. And then there's like the Stack Overflow of things. Like you have a very specific question, right? And you want a very specific answer. But how do you get from like solving that MNIST or that first like tutorial to the point where you can ask normal questions that Stack Overflow is a bit notorious for people being kind of mean to you if you ask the wrong question. So how do you get from the MNIST point to the point where you can ask questions and people won't be mean to you? And it was surprising. Like after you start noticing it, you can't stop noticing it. I think it exists it's much broader than just machine learning. Like it exists everywhere, and I think that like now with the sort of benefit of hindsight, I know that part of the reason is that it's hard to define that middle ground in a way that is generally that is both accessible and also generally applicable. And so I think that you're working on something. The whole point of this was to say that you're working on a worthy goal that I think is hard to achieve. But I guess
it's very hard.
Yeah, go ahead.
But we need to. It's very hard. But we need to start somewhere. I totally agree. But we need to start somewhere. I don't think anybody, of course, us, has the presumption of capture in a repo or in a post or in a paper the reasonable scale. But the presumption is some of the patterns that we showed working for us, they probably work for you, were you reasonable scale practitioner as well. To start, it's not going to be the end of your journey, we always say, but it's a good place to start. It's a better place to start than the Flask app, and is at least a place to start that and Meta does, that you can copy and paste YouTube recommender and work with that. So it's a good place for you to do the end-to-end first and understand how the pieces fit together. And then, of course, nobody has the presumption of like solving your business case, from the outside. That's up to you. But at least there's something that we wished we had when we built our own company, right? Instead of having to invent everything, but there's nothing around that would fit our need.
Yeah, no, and I also, one other comment about this is that when we speak to companies or teams today, sometimes people reach out to us to sort of advise them on how we think they should get started in their MLOps journey. I think one of the recommendations we keep on giving to people is that the details of your first iteration don't matter as much as getting through that first iteration and building that first end-to-end pipeline that kinda works, and then starting to iterate on the different pieces and improving them. And I think that really relates to what you just said of like, here's a template for even, it might be basic, but a real end-to-end project that you can now start iterating. So you're not starting at literal square one, but maybe square 2.5, which is already like 250% improvement. That's huge.
Yeah, like the first step is the hardest one, because after you see the data flowing in the system, because at the end of the day, like your pipeline is a function from data to an API, right? Like in the most abstract and trivial way. But once you see the data flowing, you realize that many of the things you thought right were wrong, and vice versa. Like sometimes I thought that some things would need to be improved at scale, and that at the end of the day, when a lot of data comes in, it's like, no, this actually works. Like it's worth fine. It is. Sure, I can skim off 2% of that or 2% of here, but that will actually cost me 3 months of work. And again, I'm a reasonable scale person. I'm not Amazon. So my incentives is on building a robust system that works across different use cases, in not skimming off that 0.1% of accuracy, because that's worth billion, at Amazon scale. So even the thing that we optimize for a reasonable scale tends to be, velocity of iteration, like flexibility, robustness, like solving use cases of different stakeholders, more than being super narrow of like, hey, I'm just improving this part of recommendation system and I need to get it from 0.90% to 0.91. Yeah.
So I think this relates to the next question that I wanted to ask, which is, how do I know if I'm in this criteria? Like, to give a concrete story, yesterday I spoke with a company, I won't name them, they're a small startup, and they were taking their first steps in the MLOps world. But their scale, like they're already almost on day one, they have like tens of terabytes of like tabular data, which for tabular data is a lot of data, right? It's not a small CSV that you're downloading from, again, Stack Overflow and playing around with. And so to me, like I was kind of surprised by the sort of the amount of attention they need to put in to setting up their first version. But maybe that's not exactly what you're talking about, because it's not it might be like a orthogonal dimension, right, to what you mentioned a moment ago. So yeah, so how do I know if I'm a company, if sort of this idea is relevant for me?
I think data size is definitely one of the concern, because the bigger the data, the more, like, again, remember, we're striving for end-to-end velocity and iteration at reasonable scale. We're trying to get a system that requires very few people to be up and running and to be maintained, possibly without ever touching infrastructure. Like one thing we're very adamant is like people that runs business logic should never have to touch infrastructure. that should be taken care of by your tools. Of course, after a certain scale of data, this becomes impractical, right? And the terabyte scale, I think it would be the upper bound of this reasonable scale. We also have terabyte scale data. And for that, I still think that when chips are down, because sure, you have terabyte scale in data overall, but you never really train on the entire terabyte scale, you know what I mean? And the terabyte scale is something that, for example, Snowflake will easily support at a reasonable cost when you work on. But if it comes petabyte of data, then it will cost you like a fortune just even to run a SQL query, and then maybe you have to try to use other stuff. So data is one dimension. So surely, I think most people will have between the low terabytes or like high gigabytes type of thing, and this is where we are, and which is still a lot of data if you think about it, but it's not the Uber scale. The other thing that you need to consider reasonable scales is your resources, right? Like how many people literally do you have in your team? Like again, if you read online, there's like this data team of like there's a data science, a data engineer, an ML engineers, an ML person. Like how many people do you even need to start? Like do you need 5 people to even get one endpoint off the ground? And maybe you have 5 people, good for you. But the reasonable scale is typically the ability of doing a lot, with very few people. And the other thing, of course, again, as I mentioned before, is the marginal value. Like people at reasonable scale get marginal value from their models and their sophistication, which is good, but it's not billion of dollars good. Like the value for people at reasonable scale is mostly solving a problem where before there was no ML or low sophistication ML. Is not going from, again, Amazon Recommender to Amazon Recommender plus plus. This is not what the reasonable scale is about. Because at the reasonable scale, marginal improvement rarely will pay off for the cost and the increasing complexity of what you do. Okay, it's a very big difference with other type of ML like practices. So if you're asking the question, you're probably most likely a reasonable scale person. Because if you weren't, you probably would know that already. Because nothing will fit you. Snowflake won't work. Metaflow won't work. Like you would have to even use 4 GPUs even for your smallest models and so on and so forth. And that will kind of introduce a lot of complexity. I'm not saying there are not vendors or solutions that you can use. There are. Again, the situation is not the same as when I built Tuzo 5 years ago. It's very, very different. But it's significantly more complex than our typical repo, like the one we presented at NVIDIA last week, right? That is for a recommended training on a couple of millions rows, like 5 million rows, which is for a tabular data. It's still like, it's still like a reasonable, it's still like a reasonable quantity of data, but that runs end to end with no infrastructure, and 1 GPU is more than enough to do the entire thing. If you go above that, you may need to restructure some of the things. That's my point. So yeah, like it's not like precise, clear-cut boundaries for the reasonable scale, but I think most people know when they are in it.
Fair enough. Yeah, no, I tend to agree. I guess one question that I have is, would you say that the answer is different if you're working on unstructured data? Like if your images, NLP, I don't know, MRI data, does that change, or is there still a notion of like reasonable scale?
No, I mean it changes because in some type of data are like by definition more bulky or like more costly to just shuffle around and kind of train on. And you make very good example, like a structured data, of course, is a very good example. We do a fair amount of NLP though, so I think that thing was like, and for us it's working fine with the structure we have, because most of our NLP projects are let's say tabular plugin these guys, meaning there's like NLP just like the free form text is basically the input, but then the output is going to be a classification or like a relevant judgment or something like that. So at the end of the day, the pure SQL based aggregation that you get with a modern data warehouse is actually still fairly useful to prepare data for our models. So that hasn't been like a major complication for us. But it's also a combination of that plus the fact that deep learning doesn't really require much feature engineering anymore. So like the data that I get from the warehouse can basically be sent to BERT, like basically as it is. So cutting all the pandas stuff in the middle, like a lot of the data wrangling that a lot of people used to do in notebooks and pandas and so on, in our world very rarely exists, or it's a very, very tiny portion, because the bulk of the aggregation, joining, and all of that stuff is done at scale with SQL. And then when you pull down the final data set in your Metaflow pipeline, you just have one final table, which is basically 99% done. And then you basically take that and and shove it to the GPU in the cloud, and then you get back the model. So that's kind of our typical thing. So I would say that even for images and text, there's an argument to be made that reasonable scale is applicable. Of course, again, up to a certain, up to a certain point.
Fair enough. I think that this makes total sense to me, but it seems to me like if we dive one layer deeper, we would and you were also kind of alluding to this, it's come to the conclusion that it's a spectrum, right? Like you start from fully reasonable scale and gradually make it into totally not reasonable scale. And it probably can happen on like multiple dimensions. So maybe on the data side, you are not in reasonable scale, but on the training loop side or the GPU side, you are, or whatever that is. And so you might be able to mix and match. I don't know if the materials that are out there cover that. Like if in this specific case your data is too large, here's what you can still get. But maybe that could be like a next step.
Totally agree. I think you can, in theory, have not much data, but very sophisticated model. Mm-hmm. So now your old GPU loop cannot be, maybe needs to be kind of refactored a bit or return a bit. Or maybe you have normal data, normal models, but your latency constraints are so crazy that you can, SageMaker your way out of it, or DynamoDB your way out of it because you're caching prediction or stuff like that. So all of this, again, there's no one size fit all. Sure. But my point is we tend, as a field, I think the message is we typically tend to overcomplicate stuff, not oversimplifying. My usual analogy is that everybody's trying to play tennis, and the only material we'll watch is Roger Federer training, which is amazing. Roger Federer is an amazing tennis player, but very few people will become a professional, and certainly not right now. We're just trying to learn how to get the forehand and the backhand on the other side of the net. That's what we need to do. There's always time to become Federer if you're talent and whatever makes you become Federer. But that's right now most an inspirational thing. So that's what I'm saying. People tend to think that things are way more complex than what they are, because they think they need to get the perfect model or the perfect pipeline out of the door. That's never the case. You need to get a pipeline out of the door that works end to end, get data flowing, and then decide what it means to be better. But you don't need to be all flashy with bells and whistles at day one, because if you're at a reasonable scale, there's no value into that. Again, velocity beats accuracy every day of the year.
I could not agree more. I think iteration speed is undervalued, and accuracy is overvalued for most of the people we speak with, and that makes total sense. I think the companies that do get to that point really see the benefits. There's this hurdle of getting there first time and realizing that you can, wow, I can now iterate so fast, and then you realize the value, and then it's much easier to commit to doing that further. So let's dive into the nitty gritty detail. If I'm team lead, head of AI at a startup, and I'm hearing this, and this sounds really exciting to me, and I'm also now on my journey to build out my MLOps platform. How would you recommend that I approach this challenge?
So start by the things you need to get out by definition, right? The main so data ops, where the data stores and how you organize your data. And then the training loop, and then serving, right? Without these three, there's no machine learning. Without these three things, there's no machine learning. So and then we can discuss all of the rest, experiment tracking, monitoring, and so on and so forth. So for the data side, there are many solutions because, of course, data is been there before machine learning. Okay. My suggestion would be, again, especially if you have semi-structured data or fully structured data, go with a data warehouse. It can be Snowflake, it can be BigQuery, it can be a Redshift, it can be whatever you want. But just go with a managed service. They're going to scale, basically the computation for you without you worrying much. Okay. Mm-hmm. So that's point number one. Make sure you respect, the modern data patterns of logging stuff, having replayable infrastructure, and so on. All of that is online. I'm not going to go into that. After that, make sure you have a good training setup. Training setup means a place when you can, get the data that you transform from your data operations and be effective in training a model. Effective means it's easy to scale it when your data grows a bit. It's easy to reproduce what you've done. It's easy for everybody to do it in their own laptop or in the cloud, whatever they are. It's not like it works on my computer, but then it doesn't work on anybody else. Our suggestion for this part is an open source tool fully free. It's called Metaflow. It's been open sourced by Netflix a couple of years ago. And for us, it's been a game changer in how we structure our training pipeline. And we can discuss why. And then finally, serving. As in, at the end of the day, we need to make an impact in people's life. So if the only thing we're doing is training, nothing's going to happen. So we need to have a way to get the artifact, which is the results of our training, facing our user. What our user may mean B2C user, that is, shoppers in an e-commerce, or maybe internal user for an enterprise use case, okay? And serving can be done in many different ways, especially if you start with a simple model. You can start with PaaS or even SaaS solution that are kind of off the shelf, and they will take away all the maintenance of like auto-scaling the endpoints, making sure, the latest model is running, and so on and so forth. And again, we can go into the details of how it works. Once you have that, the last thing you need to make sure is that whatever is your prediction, when a user leave you a feedback, that depends on your use cases. But like in recommendation or search is easy because you show something to the user and the user click or not. Make sure that click goes back into your data ops and that is joinable with everything else that you do, right? So make sure you basically have a full loop of data from training, from data in the data warehouse, transformation, training, serving, feedback, back in the data, and again the loop. It's a continuous circle. Data that cannot be joined doesn't exist. It's a fundamental point. You may have all the data in your warehouse, but if your data is not interjoinable, it's like it's not there, okay? So make sure that everything that happens in your journey is logged and is joinable. So every prediction you serve is going to have an ID that is going to be linked to the click event of the user that is going to click on that. And that ID is going to tell you which model has been trained and which data set has been used to do that, and so on and so forth. And all of that needs to be in one place. We call it a single source of truth, which is the idea that your Snowflake is a representation of your universe. Like everything that happened in your universe, your startup, is there. There's one event for everything. Everything is logged there. It's like a blockchain, like a perpetual log of all the events related to the company, okay? And once everything is there, you can do magic with it. So I don't know if that answered the question, but this is the type of thoughts, like thread of thoughts that I would use if I would have set up a new stack again from scratch and say, hey, this is the type of company that I want to build. Once you get this in place, everything else comes almost for free.
Yeah, no, that connects also to, I guess the way I thought about this before we spoke was what you defined sounds a lot like what is sometimes called building an active learning loop. So basically, we love DAGs. That's why we call the company with it. But obviously, in the ideal case, your DAG is actually not a DAG. Like there is an edge connecting the end of your pipeline, which is deployment, back to the start of your pipeline, which is, I don't know, labeling or just storing the data in a way that actually makes sense. And so this totally resonates with, I think, something. It's I guess surprising to me that today, after machine learning models being in the market for so long, that still it is very rare to find companies that have a proper active learning loop in place. Like sometimes companies close this loop, but the last connection is very, very manual, and the automated closing of the loop is very, very rare to see at all scales in my mind. Like I'm sure that Google and Amazon have this, right? But for anyone else, I think it's very uncommon. So that makes total sense. And then a question about the point that you made is, to be clear, so you sort of stated broadly 3 components, right? Which is like data, training, deployment, right? And so as I understand your recommendation, obviously each component will need to be adapted to what this theoretical company or team needs. But you want to have all 3 in mind and make sure that this is sort of the these are the components that need to be put in place. And until you have put them in place, you probably don't have an end-to-end pipeline. So is that correct so far?
I agree. Like totally agree. I think without these 3, you may have a prototype. You may have an offline system to show shareholders. You may have maybe a data warehouse for visualization and descriptive statistics, all valid concern, but you don't have an ML story. Like you don't have an ML pipeline. You're not running ML like at scale.
And then, so for each one, you mentioned a few things which I think are fair, but to make this harder harder than it sounds endeavor, right? So what we find a lot of times is like data ops is like whole other story, which we should probably get into later. But let's talk about training because everyone likes to talk about training. So a lot of times people will say, well, we solve training, right? Like we can use whatever, SageMaker, Metaflow, some orchestration tool that runs the training for us. But it's not really reproducible in the sense that we had this run a few months ago and someone left and we can't now find it anymore because it wasn't tracked properly. And then you get into this point where like, and this is, I guess I'm trying to ask a hard question here, right? But how do you make sure to balance not getting into the weeds, so not over optimizing for this, while not getting to the point that you built this entire system, then 2 months later, you can't reproduce anything because you didn't invest enough in it?
So I super agree with the problem. I would say that some tools make it easier to make the right choices than other. I mean, you guys, DagsHub, have like at the master of open source, like of of the open source tools in this space, and you also support like native experiment tracking and so on and so forth, which is super important. I'm not saying it is. If you starting with a case that I mentioned, just because I'm used to it, but there are alternatives. Like Metaflow actually automatically version everything for you. So there's never the case that you run something and then somebody leaves and you don't know where the things are. You always know exactly where things are because everything has been snapshot for you in AWS as an immutable artifact. So every time you run a Metaflow pipeline, a Metaflow training, everything that you version is going to be forever in your S3, for example, and is always going to be linked to that exact run with that exact artifact with that exact variable. You can actually inspect the state of any variable at any point in any run in the past, irrespective of who did it in your company. Okay, so that problem is kind of like automatically self-solved by Metaflow. Metaflow dataset, I know you guys are really good at like dataset versioning and inspection. Metaflow doesn't have that out of the box. So what you can do, you can version your dataset as an artifact, fine. But then you don't get some of the things that proper dataset versioning tool will give you. Okay, just to be clear. But it gives you a first start. Like if you want, let's say, I would say soft lineage, as in always the possibility to know exactly which data produce which model produce which prediction, and which clicks what's related to that model. You can totally do that. If you're really, if data versioning and data slicing is really important to you, I mean, you guys are certainly know way more than me in this topic, and I think you should supplement this barebone Metaflow with something else. Okay, but at day zero, the replayability and debugging, at least with Metaflow, is partially solved for your first iteration. So on that, I would say we as a team, we're kind of happy with where we are. But we recognize that there may be other open source tools or other things that we can put on top to go to the next level of, ownership, accountability, reproducibility, and so on.
Interesting. So one last question about this.
Sure.
The other side of this coin is a lot of times, and I generally agree with the notion of like logging as much as possible. Like you can never log too much because you can always filter things out. You can not log enough and then regret it later. So generally speaking, you should err on the side of logging too much. But one of the challenges, and we see this a lot with, let's say, catalogs of sorts, right? Which is the problem of like garbage in, garbage out, and finding a needle in a haystack. So I'm curious, like I'm less familiar with Metaflow than you are. So it would be interesting to hear how they solve it, if you know, and if not, and maybe in general, like how you would approach solving this, because you do want that balance of this is important, so I want to mark it as important and have this, stored forever, and this is less important, so I don't want this polluting my namespace, right?
Good point. So I don't think there's any answer out of the box. If you use Metaflow, for example, I think is more about what you think is important, and what are the best practices you want to set around. I think the versioning and reproducibility about Metaflow are super nice to have feature, but at the end of the day, it falls on you as a practitioner to decide, what you want to do. And the system right now is built for people doing the coding, more than for people doing, managing artifacts and so on and so forth. So I think there's still some road to do in that sense. A couple of points though. One is there are some things that you may want to store and be visually persistent because they kind of capture some of the functionality or some of the things you deem important from a run. Metaflow as the card decorator, which I'm super proud of because it was co-developed with us. And is the idea that you can just decorate your flow and then automatically you have basically an HTML, like a page, or like summarize all the artifacts where the data come from, the lineage and so on. And you can kind of show it to other people in the company, maybe technical, non-technical, and you can use that as a way to encode documents what you deem most important. So I think that's topic number one. Topic number two, there's another point of logging which I think is even more important than the machine learning one, which is the data lineage one. Like, as much as it, again, like, and you touched on this before, like, as much as it's important for me to know which exact state of this variable was when I was training this model, of course it's important. But I can always retrain a model. I can never get a data that I didn't log back. Like, because the data is about the external world, I cannot rewind the external world to my pleasure. Well, I can train my pipeline as many times I want until I get it right. Yeah. So when I say logging is important, I think the first thing we need to make sure of is logging your predictions, is logging your user action, logging the data that comes in from data sources. In our case, is e-commerce catalogs. Like, make sure that everything that you have a dependency with the external world gets logged forever in the right part of the system, because you can never get it back. You can't rewind history. That's a fundamental problem of the real world. We can't go back. I mean, unless we invent time travel. But then if we invent time travel and we use it to get data back instead of going to see the dinosaurs, I think we're gonna miss a huge opportunity. So my point is, log all the data you want, especially about the external world. Don't save on that, because you never know when they will come useful to you. And if at some point you have a project and now you didn't collect the data before, now you have to wait 6 months from when you decide you want to do a project till you have enough data to do it. While if you think about data logging in advance, think about this idea of Snowflake is my universe and everything about my universe should be there. When you want to test a new idea, like when we want to write a new paper, 99% of the time, we have years of data for that. Even if we never thought about this before, we have years of data, billions of rows we can just use to validate our ideas. And that comes because we thought data through before anything else, before ML, before NLP, before anything. We thought data as the fundamental piece of our company, which I think is super powerful and very underrated in many aspects.
Yeah, no, that is sort of speaks to the point of treating data as a product. I think there's a hidden benefit to what you just said, which is sometimes if you didn't collect data and you now need data to validate a hypothesis, you have a larger tendency to maybe cherry pick or introduce bias into the way you collect the data because you already have a hypothesis in mind. Whereas if you just collected all the data you could and now are testing a hypothesis and you validate it, it's more likely that it's true and that there wasn't a problem in the data collection because you just collected it without having that in mind. So I think this relates to a very general point, which I was trying to make earlier with data catalogs and everything. And I think that unfortunately it's not as widely applied in the industry today, which is like everything in life, you sort of reap what you sow, right? So if you don't collect data, it might cost you less storage, but it's going to cost you more on time to market and getting to the product or the hypothesis that you need. And also in the same sense of how you document your machine learning journey, it's better to err on the side of logging or creating too much information so that you're not lost later. But the other side of that is you need to remember that if you do a low quality job of creating that documentation, then you might pay later in that the documentation you created seemed like you did the job, right? Like you logged information, but you logged it in a non-usable way, so it's not going to be as useful. So I would still rank it better than not collecting anything, but it's even better to put some thought into how are we going to document this so that it's useful later, and what is the job to be done with the documentation. So again, this is meta level product management. You're not just managing the product that your company is building, but you're managing the internal processes that you want to set up for your system. So if you think about what that is supposed to accomplish, like reproducibility, like being able to find a needle in a haystack, then that might affect the way you decide to document these things. But I totally agree. So asking a very practical question, when did you deploy your first model to production, and how did that process look like?
So I mean that really depends on the concept of mod. Like I think there's like in the modern concept of model,
Mm-hmm.
like really modern concept of model, to production meaning like to like millions of people. So not like a small like prototype for a startup and so on. Would be like a time of Tuzo. So Tuzo was
Mm-hmm.
a small company. We're processing like north of 100 million events per day, including search, recommendation, and things we use. So dozens of millions of people have been touched every year but our API without knowing them, and hopefully we made them life slightly better, like super marginally but a bit better. And our first model, so Tuzo was doing, so for people who didn't know, Tuzo was doing information retrieval, so search and recommendation for e-commerce use cases. What it means is that if you have an e-commerce and you have the search bar, and you know that the search bar sucks, like there's a general experience that everybody, you can find anything online. The answer to that is that search is actually very hard.
Yep.
And people think that search is solved because they have Google, but Google cheats in so many ways that you can't actually reproduce, so that doesn't really solve the problem. So when you actually have to make a search that works on a reasonable scale side, it's actually very hard. So what Tuzo would do is like we'll give you API that behind the scene. So when somebody types blue shoes by Prada on your website, instead of using a standard search engine, you will call Tuzo API. Tuzo will do some magic in NLP, understand that blue is a color, shoes is an object, Prada is a brand, and kind of give you relevant results. And then you would just, paginate for the user. So you wouldn't even know that Tuzo was there because it was a behind the scene call. But Tuzo will power different e-commerce with its capabilities. So sorry, that's kind of the use cases. So Tuzo have two main models for search. One is shallow parsing. There is the magic that goes from blue shoes by Prada as a string to understanding that one is a color, one is an object, and the other is a brand. And then, of course, re-ranking, meaning that once you get the result set, so there's a retrieval step, you get things that you think are relevant, and then there's a retrieval step, which basically takes into account popular items or like what the user bought before or something like that. Okay.
Mm-hmm.
So the first model was a condition. I mean, I think we can say this now. It's been many years. It was a condition random fields. It was before deep, like large language model. It was before all the things that exist today. So it was a condition random fields. It was a very fast model that you can run you can run without GPUs.
Mm-hmm.
And it was like a doc. It was like like the tutorial in tutorial. It was like a Flask app because at the point it was just flat. It was very fast API. It was a flat app with a Dockerized. It was basically a Dockerized containing Fargate that we had, and it was like using Fargate for like auto scaling and kind of managing programmatically our like deployment part. But it was a very simple Flask app that would just take the input a string, run the conditional random field model, gets you the tag, so it gets the string as input, gets you the tagged word as output, and then that will actually be sent to Elasticsearch for like retrieval and then re-ranking and so on and so forth. So it was a very simple thing. It was literally another lifetime, but yes. So that I would say that's my first, let's say, effective model, meaning model at like millions people scale that I deployed.
So my takeaway from this is that even the crummy Flask app is possible. Like you can possibly use that to serve a very large scale, which I think also proves your point.
It, it is, but at the point, the model was very simple. The model
Mm-hmm.
occupied like you can literally load it in memory in a Flask. The model is very, was like very
Yeah.
small. So that's one thing. And the model was very fast. As in, even on CPU, that things takes like, very little to compute. So there's not much there was not much thinking going into that because it was kind of just works. Also, the queries in e-commerce tend to be short.
Yeah.
So the models needs to run on 3, 4, 5 tokens at most. So I think that the combination of all of this made it possible to keep the deployment side as easy as possible. But that goes back to my point. Like there's no need to overcomplicate. Even for things that actually runs on millions of people, there's no need to complicate things. If you thought the end to end, like if you thought the thing through, it may be that a single PC may actually be simpler than what you expected.
Yeah. And then like all the way from then to now, how do you see sort of like if we're focusing only on the deployment, the productionization process, right? How do you see that it has changed over the years?
So there's two distinctions. First is that, of course, Tuzo was a smaller company, so I had to be involved in every single decision, every single things to do. Coveo is 1,000 people company, so there's like entire team to do things that it used to be under my like under me. Now there's the entire team that like way better than I am and way more focused than I am on doing that. So Coveo serves like 700 customers right now. So like there's a Kubernetes, we have our own clusters to on AWS to kind of like, do the serving, and we have our own serving infrastructure. So it's a very different, it's a way more custom and very different setup than Tuzo, but also justified by different resources and kind of like different scales. And that's for the CPU part. On the GPU part, I think we are still learning, like everybody's still learning. I mean, again, outside of, maybe Facebook, but like everybody's still learning how to do that effectively. Effectively means cost effectively and in a performance effective way, because the more our model gets complex, again, now there's no more condition random fields. Now people tend to do harder things or like more complex things. More complex meaning the footprint memory is much larger and the latency is much higher. Like, in some use cases requires more than 5 tokens. So like all of these things makes deployment actually not super straightforward. And I think it's an open question of like, what would be the best thing going forward. We have evaluated open source stuff like Triton from NVIDIA as your, basically deep learning specific infrastructure. We've evaluated past solution like SageMaker, for example. You just given the artifacts and they kind of deploy it for you, scale it for you. We have evaluated RayServe, so the serving part of Ray, the open source framework, and the company, the SaaS version with AnyScale. So we're actively looking around to see what actually would suit our need. And again, I think this is a reasonable, not solved problem. Like simple models are commoditized, like deploying simple models, like we do now, a conditional field are commoditized. Like a scikit-learn model, like a random forest is a trivial thing to do.
Yeah.
Or even a simple vanilla LSTM or something like that. SageMaker, TensorFlow does a decent job of it. Sure. But when you get into complex model, like when you have to do retrieval and ranking, like in recommendation and search, or when you have some custom dependencies and so on and so forth, that's where we find out that even the AWS stuff kind of falls short. And then you will need to fall back on other open source stuff, but then you need to maintain them. And now, now the problem is like, oh my God, now I need a team to maintain my Triton stuff because I can't just ask AWS to do it for me. So I think this is an interesting area. It's not my area of focus or even my area of like, let's say, super expertise right now. But I see this at our company or company similar level of sophistication and scale of being an active discussion. I don't think we have a solution for this yet. Like deploying complex model, I think is still hard. Deploying simple model, I think is a trivial task and it's been solved.
That's actually very surprising. Like you are basically saying that a company like Coveo is hitting the walls, right, of what is conveniently possible today with deployment. I would like coming into this talk, I would not have expected that that's the case. Like I would expect that it might be expensive, but it is a solved problem, and you're basically saying that from your experience at scale, it is not.
I mean, so there are two combinations of things. First is that Coveo was really early in the machine learning side. So like in our space of B2B company offer machine learning, and there's a lot of good companies in the space, but Coveo was honestly the first one to bet on this more than the other one, right? And that's like public public verifiable information. So a lot of the things that made Coveo successful in the beginning were being in the early side of this. So we're like shallow models and so on, because deep learning wasn't even there, right? You know what I mean? So now, as all pioneers, as the people that invented things first, that innovate first, now we need to update stuff to the second wave. But no, we still have like hundreds of clients to maintain on the old stuff. So there's one challenge of being first at doing stuff is that now you have two stacks and you kind of need to do that. And that's a known problem for innovators. So like it's not specific to Coveo. The other point is our B2B nature. So remember, like we can, at a limited budget, we can sell whatever we want. But since our model needs to work on 700 customers of very different scales and sophistication and constraints and latency, we can't just throw money at the problem because with 700 customers, it won't work. Yep. That's again, like the difference that our model performance doesn't immediately translate into money that goes into your pocket, like for Amazon or Google or Facebook. Yep. So our trade-off between the constraints of our GPUs or like, our latency are slightly harder to
Offset.
navigate or
Yeah.
less transparent to navigate than so there's way more discussion of having like, hey, if you move this from a pure CPU model to a GPU model, this is what it's gonna cost, but what's gonna make us? Like, what's the ROI on this? And this calculation is surprisingly hard to make.
Yeah.
So that's why I'm saying, like, you need to be way more cautious than just throwing a GPU at the problem. So I'm not saying there is an impossible problem to solve, but it's honestly not. Again, like I was, when I got deeper into this problem, I was also myself surprised of all the variables that goes into that. Coming from my conditional random field, I was like, wow, now the world is really changed. And I think again, it's a genuine, with this constraint, it's a genuine problem. And I think if it's a problem for a company, sophisticated like we are, I think a lot of other people are struggling into that. The fact that there's a lot of offering, paid offering on how to serve transformer models, for example, Hugging Face is one, for example, makes me think that this problem is actually way more, general than what, because if it was just that trivial, nobody would pay for it, right?
Yeah.
Nobody would really pay a lot of money for it. So I think a lot of people going into the transformer revolution are finding generally not obvious how to make that impactful with, again, given some constraints.
Sure. Yeah, no, I guess it makes, I agree with you. Like the fact that there are companies getting paid to do this means it's not an easy problem to solve. The sort of flip side of that is, like, can a generic company that does, for example, deployment of GPU models serve the use cases that a specific customer needs, or is it like a very customer specific problem? I think that one thing that this brings up is like pipeline orchestration, right? Is a problem that you have generic solutions that enable orchestration, but in the end, when you talk to companies, each one is still, for good or for bad, a special snowflake. And so even if you can use generic tools, you can't use them in a generic way. Like, there's a lot of custom tweaking that needs to go into actually making the pipeline run in a way that is valuable, like from a business outcome perspective for each company. So my personal leanings is that that's the same for deployment. Like, you still are going to need to have a lot of input, and I maybe I'm wrong, right? Like, here's the controversial prediction. Like, I am estimating that for interesting cost-effective use cases, it's probably never going to be like a drag and drop, like here's the model and then poof, it's deployed, right? You're still going to need to invest some time and maybe money into making it work for you. But yeah, I agree. It's like a hard engineering problem, hard business problem. It's an interesting one.
Like, I agree 100%. I don't think that's why in these cases I think tools, in this specific thing, tools have an edge on platforms. Because a platform, like a closed software, the drag and drop, metaphor that you used, hopefully that is a metaphor. It kind of force people to change their company or their needs to fit one particular workflow. And in my experience, it never works for. It is for people above a certain level of sophistication. That doesn't really work. But tools can abstract away what I don't want to do and leave me the 20% that I need to figure out myself. Like, but you know what I mean? Like, in the serving space, like there's a bunch of companies. Like, I mean, the big cloud providers have decent solution, again, with some shortcomings. There's a company called Exafunction, which is very good, that also tries to solve this problem of like serving like a lot of prediction at scale, mostly for autonomous vehicle and stuff like that right now. It's a small company in San Francisco. But I think the point of it is getting the abstraction right, like taking out the 80% that I don't want to do, smart batching, like horizontal scaling, swapping modeling the GPU's memory and so on and so forth. I don't want to care about that. I don't know anything about it. Like, I don't want to be an expert in this. But then there's still going to be Jacopo, like understanding how that fits into how my features are computed, how predictioners are fed back into, there's still a lot of work into that. I mean, Snowflake didn't take away from me the SQL, writing the actual SQL queries, but it takes away me maintaining a Spark clusters and scaling it and having to deal with Scala errors and so on and so forth, right? Metaflow didn't really take away my Python code, but it doesn't, it makes it so that I don't have to touch infrastructure or do specific things to have a version like pipeline, And I think for serving, it's going to be the same. Like, how can some of these scalability concerns be abstracted away from me? While still, I have to do my job. Like, if we're thinking that some tools solve your job, it's not a good job, generally speaking. Like that's a terrible job to have, and it's probably a waste of your time and talent if your job can be solved by a tool as it is. Tools makes you better at your job. Don't do your job for you.
Well said. So when we first met, it was in Toronto, and you said that you have an amazing job because it combines real research, i.e., publishing papers, with sort of serving real customers. So you get the benefit of both things that people usually crave, which is actually being on the forefront of research and also being on the forefront of like applied technology. But the maybe harder side of that is that it's a balance that you need to meet. So I guess my question is like, how do you balance this? And is there like a positive feedback loop that could be built here, or is it more like a trade-off and you need to just like find a decent spread of time?
That's a very good question. So first, very true, very privileged position. I get to do a bit of two things that I like. In my life, when I do too much engineering or too much product, at some point I'm like, I wouldn't say bored, but I get exhausted by low-level questions. But then if I only do high-level scientific breakthrough, then at some point I get bored because nobody's using that. So like in my life, I kind of swung between the two extremes, and right now in my position, I'm kind of happy that I can kind of keep both, more or less in the same level.
Also,
but it's always
what
like
type of research are you doing at Coveo, just for people that don't know, maybe?
Sure. So we do quite a lot of stuff I would say 80% of our work is what I would call applied research, meaning is pushing a bit the envelope of what especially commerce tech is. That is problem about recommendation, problem about search, problem about personalization, problem about NLP, but it's always motivated by use cases, right? If you read, again, most of our papers are not, hey, we invented this new architecture or whatever. It's most of like, hey, this is an interesting problem for these people. We have data that prove that this is an interesting problem. Nobody's yet to solve it, and this is a way in which you can solve it, and then you can find our experiment. So this is our typical applied research sweet spot, which is a good thing because it's an intersection of like knowing deeply what, in this case, e-commerce is about. So know exactly what problem you have to solve, which comes from, in my case, having built in a company in the space, so I know the space very well. And then a science aspect of like, hey, let's push the boundary a bit of like, hey, this is what people tried before, but this is a new idea. So this is 80% of our, like, let's say research. 20% of our research is more, I would say, theoretical. And it's more collaboration with friends from our past or like our network of, people in university, professors, and so on. And so sometimes we have some questions that have not a direct application, meaning that they're not going to be applicable tomorrow. We don't have a use case in mind yet, but they're still in the general type of problem that we like to tackle, right? So like if I want to make an example for people, the last paper we published, which was mostly done by Patrick from my team, is a recommender system that works with gradient recommendation. What it means is that recommender system, typically you have a t-shirt and it says similar items and there are other t-shirts. Okay, that's what you do. But as a human, sometimes you like a t-shirt and you just want it darker. Or you like a pair of shoes and you just want them, flatter, less heels. Or you like a pair of trousers, but you want them shorter. How do you build that? And so our latest paper showed that if you train Clip, the OpenAI model, on fashion, then you can use, without any labeling and without any manual work, then you can use English to basically move around your catalog. And if I give you a t-shirt, you can say darker, and then you can get something that is exactly like the first one, just changing in one direction, which is color. Or I can give you a high heel shoes and you say flatter, and it's gonna get you the shoes that is the same style, but just with the heels just smaller. So what we find out is that Clips, when you train it on fashion, inside in the latent space, encode some important geometrical properties that you can use. So this is like this is more like there's not an obvious like, is it useful for a page recommender? Is it useful for a conversational chatbot? Maybe. But this is type of research that is like, sure, there's some area that we know it's important for, but it wasn't driven by use cases. It was curiosity driven. As in, we train this fashion clip and we want to know what it is. But this is 20%. This is like a minority of what we do. So sorry, like very long overview of what we do as a team. So
at this point, everyone wants to work for you. So if you're hiring, you should let people know.
So yeah, please reach out to me if you want to work with me. But so there's one way, and the other thing, which is I think is more evident in our MLOps thing, is building and product and engineering and so on and so forth. And I would say, going back to the original question, is always a trade-off between the two things, as you don't want to be sucked the entire time of doing just research, and you don't want to be stuck the entire time just on doing tooling. Mm-hmm. But it's not that we're really good at it, meaning that 2021 is mostly about research, 2022 is mostly about tooling. Like even ourselves within our privileged position, it's not that we're always so disciplined in kind of cut our time in between. Mm-hmm. So it's more goes in waves, and in the collaboration that we've opened, in the people that reach out to us, in what the business needs, in what the product roadmap wants us to do. So it's a combination of things. But even I don't want to give the impression that we kind of have sorted this out. We're trying to do the best we can. And again, sometimes we err, so to speak, on the side of product. Sometimes we err, so to speak, on the side of science. But hopefully, when you zoom out and you take our last 3 years at Coveo after the acquisition, I think hopefully what you can see is a fairly good balance between data engineering like in contributions and kind of like science and and research contribution, and hopefully that's what people see at least.
I think that is indeed very unique and privileged. So I'm sure a lot of people are now very jealous or want to just be a part of the team. So you can reach out to Jacopo afterwards and see if he has any openings. To sort of like gearing towards the end, I'm going to ask a few maybe higher level questions. So the first is, what do you think is the most exciting topic in machine learning right now, or in MLOps right now, and why?
So in machine learning, I would say, partial to my NLP thing, I'm getting more and more interested in large language models and what they can do. And I hope I will have a bit more time to explore the capabilities, or like even stuff like CLIP or like multimodal models. They're not that large yet. I mean, they're largish, but not super large. Yeah. But I'm kind of very interested to know, what's inside of these models and how can we use them for good and practical use cases, and for some, for learning something about language that we didn't know before. For MLOps, well, there's a lot of things that we need to improve in the MLOps space. One thing that I'm passionate about is online experiments and online testing and testing in general. So I think we got to the point where if you do your job properly, you can train your model, deploy it, and have a reasonable quantitative way of knowing if that's gonna work in some sense of work. I think there are two improvements we need to make. First one, and is part of the data challenge we're organizing, the Reckless library that we built out in the open source, is we need to be a bit better in understanding what generalizing means before we ship out stuff. Because especially in some circles, like recommender system is one of them, even a few errors will make a catastrophic impact on your reputation, on the final users, and so on and so forth, right? And there's nothing or very little work, both in academia and in industry, that people have been doing to have a principled approach to what we call behavioral testing. Like, irrespective of your test set, irrespective of the data you ever collected, what are the type of things you want your model to survive? What are the type of shocks you want your model to be able to endure? And that's one huge thing that I think we should be better. And on this, we are actually doing and trying to do our part in the community. And I'm happy to talk to anybody that want to work with this. The second part is online testing. That is, okay, we train a model, we test it, we use Reckless, now it's super tested, but now we push it online. And the truth of the matter is that it doesn't matter how many offline testing you do, including Reckless. The final barrier to success is always online. But now testing online is freaking hard because, of course, you have to disentangle correlation, causation, and so on and so forth. And in my understanding, it's still very hard to build an experimental platform online for monitoring and A/B testing and so on. And I know there's a couple of cool startups in this space that are working on it. But I would say right now, it's an unsolved problem. As in, it's not something you can start tomorrow and have it all figured out. And of course, guess what? The Netflix, the Stitch Fix, the Amazon of this world, they have their own experimental platform because they figure out, years ago that, the ultimate test of machine learning is always online. So these, I think, testing and evaluation are the two things that I'm most passionate about in the MLOps space.
It reminds me of the Chuck Norris meme that it says like, I guess in our case, it's usually refers to developers, but real data scientists test in production. So yeah.
I mean, honestly, absolutely. The only, this meme with the normal distribution.
Sure.
There's like, the dumb person, the super smart person, the normal person.
Yeah.
And so the dumb person says, we test model in production. And then the me person is like, no, we do, like evaluation and cross-fold and whatever. And then there's a smart person that says, well, we do test model in production. Yes. And I think there's some truth to it of like, we need to test model in production. Maybe not just that, again, because models may have an outsized impact on the world, even terrible. I think that's why we build reckless. Like, we need to catch a mistake before we ship them out, and that's non-negotiable.
Yeah.
But then there's a further thing to do, which is, well, but now let's see, how actually they perform in the wild.
Fair enough. So another thing that usually comes up is, for good or for bad, it is hard to keep up with the world of machine learning and data science and MLOps and everything. We sometimes call this MLOps fatigue. You get so tired of having so many things out there that you have no idea where to start. So how do you keep up to date? And in general, maybe if you can share how you learn new things so that others might learn from the way you do it.
I mean, that's a terrible problem, and I agree with everything you just said. I have MLOps fatigue and I have two fatigues. I have the ML fatigue, which is one way of doing that, and then the MLOps fatigue all in one. So I'm very tired and I need a vacation. That's the bottom line. But generally speaking, I work fairly well with. Sorry, it's a terrible way to do it, but it's my way, and maybe works for you. But I'm old enough, as you can see by my white here, I'm old enough to be in the space a bit, both the ML space and the ML space. So I like to think that I develop a taste for what type of things I like, what type of papers I like to read, which type of authors I follow, and which type of people I like. So I kind of use this taste and the implied network of this taste. Like if a friend of mine wrote a paper or a friend of a friend wrote a paper, I'm more likely to read it. If a friend of mine or a person that I met at a conference that I go to, for example, I'm more likely to be friended. Mm-hmm. And it's kind of like, this kind of like, word of mouth, virtual word of mouth type of thing that helps me at least get to a reasonable amount of things that I can possibly try and learn. Mm-hmm. But I'm still failing at this. And of course, I'm blinded by my own biases, right? The fact that you're not my friend or a friend of my friend, or you don't go to the same conference that I go, doesn't mean anything per se. Maybe you build the best thing in the world and just annoy it. But, I have 24 hours a day like everybody else, so I need to start somewhere. And I've been lucky to curate my friends, but also I would call aesthetic taste in a way that I can kind of like figure out very quickly if something is something that I enjoy or not. So that's the general thing. The other thing is I do it less than before is once you reach a certain level of happiness with your stack, in the case of MLOps, don't go and try to, change something. If you're already happy with something, it's totally fine to spend like an afternoon trying out like an alternative. But don't try to always have all the pieces of your pipeline, the last shiny toys. Okay. So once you're in a good position with something that you like, let's say Snowflake and DBT for that transformation, they're not perfect. And there are many ways in which I complain about this, but they're good enough for now to not be a blocker of anybody else. I'm not going to test another, 3 data warehouse just for the sake of it. I'm fine with it. And if it's not a problem, don't fix it, right? That's a general thing. So it seems like I'm in a mature position enough that a lot of things that I want solved are solved. Sure. And I have a very opinionated view of what needs to be solved, of course, and how things need to go. But that kind of helps me narrows down the amount of things that I need to read. You know what I mean? As and I can totally, try something else that is not Snowflake, but I know it's gonna try it for a weekend, but I'm not really gonna invest much on it. While if somebody comes to me with a deployment solution for large scale models, I'm like, well, I'm gonna listen to this and I'm gonna focus my effort into this. So like if something works and you're happy with it, again, keep reading, but probably is the last thing you want to change in pipeline. Like start from your pain points,
Yes.
from really what you really feel you don't understand or you're not happy with, and then you work on the other side.
So
Sorry, it's a very disappointing answer. It's a terrible suggestion, but I honestly haven't met anybody that solved it. Like, if you have a solution, please, let me know what you do, because I have no solution for this.
well, first things first, you should listen to my talk about solving MLOps problems for first principles, which basically says what Jacopo just said now in like 5 minutes, but I take 30 minutes to say it, so it's better. No, but jokes aside, I think that first, like, this is like a psychological comment, even, I think the first thing that you said, which is you need to be able to feel comfortable with the decisions that you make. And part of that is, believing that you are qualified to make good decisions. But the other part is realizing that no one is perfect. And if the solution is good enough for you and you didn't make the optimal solution, there is a solution out there which would be even better, but it's like just 2% better, then it doesn't matter. And because you only have 24 hours in a day, you might as well spend those hours researching tools, but the tools that are supposed to solve the biggest problem that you have, and not a problem that you might have in the future, or that you had but you solved decently, but maybe there's a better solution for. So I totally agree with that, and I think that the moment you do that, you will also have better questions to ask the people you meet, so they will lead you to resources that are sort of more condensed knowledge, as opposed to if you ask questions like, help me solve MLOps, right? Which is basically what I asked you at the beginning of this, right? But even your mental model is very useful, because it basically says, if you don't have anything, you should start with these 3 things, right? Like, everyone can hold 3 things in their head. It's easy. So you just start with 1 or 2 or 3, whatever you want, and start with one of them, and then continue to the other 2, and you'll be good to go. So I think those are words of wisdom. I like that.
Cool.
So another maybe broader question is, how do you imagine the ecosystem for machine learning in, like, let's say 10 years from now? Like, where are we going to go? Or 5 years from now? Maybe 10 is too hard. Yeah. Where are we headed?
Yes, I mean, 10 years from now, I want the flying cars. Like, we're already late. We're already late on the jetpack, or the robot maid in my house to prepare me cappuccino in the morning. So, like, generally, like, I don't know, and prediction is very hard, especially about the future.
Yes.
So my point is, the ecosystem is amazing. So first thing, the positive thing, and they're not retort. I mean, I don't have a horse in the race. Like, I don't work for an MLOps company, so I don't have, like, I hope I can be as neutral as possible. The ecosystem of MLOps is amazing. And made me young again. Like, being part of this community, meeting you guys and people like you at Toronto, and kind of being involved online, with the guys at Outer Bounds and Metaphor and so on and so forth. It's been honestly one of the best pleasure of my last 3 years. Like, the community is made by builders for builders. The average quality of the people in the MLOps community is super high compared to other type of community. So the typical interaction that I have with people in the community is super pleasant on many different aspects, and I've learned so much from people like you, and so I'm super thankful for the community. The bad is that the community is very fragmented in a world that is rapidly changing and evolving. Okay, so everybody's betting that this market is going to be big, because we all want a future when ML is not done by Amazon and Facebook only, but it's done at reasonable scale. Like, everybody wants that future, because A, is a bigger market, because you can sell to Facebook, of course. And second, because, it's going to be probably a better society if the benefits of ML are spread across, the vast majority of practitioners, instead of being, again, only for, like, 3, 4, 5 companies in Silicon Valley. But nobody knows if that's going to be the future. Like, people has been wrong on markets before. in many sense, people thought some markets were super small. Remember the guy that said the mobile phones and McKinsey, mobile phones are not a thing?
Yeah.
Well, that was wrong. But there's also a lot of things that we bet on that they didn't go anywhere, like, in some sense, right? So I don't know. I would guess, if the market doesn't grow as fast as people think, some consolidation is going to be in order, because there are now too many players. The market is too fragmented. And if the market doesn't grow proportionally, there's not enough traction. There's not enough people
Sure.
basically to sell people to. So some startups, it's the Darwinian part of the growing ecosystem. So startups are gonna die. Some startups are gonna just be acquired by bigger startup or being outfunded by other startups.
Sure.
So VC are gonna play a huge role in the I think the next couple of years are gonna play out as they're gonna help pick the winners in some sense. Because if the market doesn't give you the money that you need to grow, you need to get the money somewhere else, right? And so your ability of attracting funds and talent is going to be a paramount important.
Sure.
So that's the bad aspect, not bad aspect of it, but it's a confusing moment, as you said, there's fatigue, there are so many vendors, so many things and so on. And it's unclear, I think it's a safe assumption, it's unclear how big this thing is going to be. Everybody's betting that it's going to be big. Like some of my best friends are doing MLOps company, and a lot of people that I think are super reputable and super good, like yourself, are doing MLOps company, and everybody wish this to be the new electricity. What is the metaphor? Electricity, the new steam
oil,
thing,
yeah.
steam engine, whatever, the new oil, whatever. But I think there's a lot of work to be done to make that reality, right?
Sure.
I think this is not just going to materialize by itself, because as much as I say that MLOps reasonable scale can be done, for normal people and normal company, ML is still a mystery.
Sure.
Like it's still a black box with magic inside, and nobody really understands how they work. So as a field, we will need to do a much better job than what we're doing to really make ML palatable or even relatable to quote unquote normal people, non-ML people. Okay, so
Yeah.
that is the work that you have to do.
Yeah.
in the regular. But I don't know if you agree. Like everybody is different. Like, what do you feel like being an operator, like somebody that is actually skin in the game right now?
Sure.
Like, what do you feel like aside from the excitement, which I think everybody would agree to that?
Yeah. Yeah. No, I think that I want to be very self-conscious in the sense of I have skin in the game, but I'm also sort of, because of that, I might be biased in my answer here. The way I see it, and again, like we started working on DagsHub like over 2 years ago, right? Like almost, I guess, 2.5 years ago. And the world now is very different than what it was then. So like the rate of change is huge. It's not something where we're plus minus in the same area, but we have like more tools or something like that. I just like on a very personal note, like I just bought last week, I bought like a robot vacuum cleaner, right? And I remember when the first iRobot came out, and I had like a more well-off friend that bought like the first version, and it was bad. It was just not good. It would like bump into things. It would like miss spots. It was just like I mean it was like a marvel of technology, but it was more of a gimmick. And the one I have now is awesome. Like it can identify each of the like furniture pieces in the house, and it knows what they are, not just that it's blocking its way. So it knows where the couch is and where the bed is, and that this is a shoe that's standing in its way, and it knows to slow down when it sees my dog or my cat and things like that. So there's like technology that didn't exist or that wasn't as refined a few years back. And I see that with DagsHub users as well. Like the amount of, we talk about like democratizing machine learning and everything, but you can reasonably create models that do really cool things today, right? Like even the like DALL-E Mini, right? So you have DALL-E 2, which was created by OpenAI, which is a huge organization. We have DALL-E Mini, which was created basically by a few people, right, that had access to more resources than an average person, but it wasn't like $1 billion funded research organization. So I think that democratization will sort of go hand in hand. And I think that, for example, ML on edge device or TinyML has a huge role to play in this because it is by definition accessible to more people. So that's where I would, if I had to bet on where some of that growth is going to come from, I would sort of agree with you that maybe the more classical use cases of like churn prediction or something like that, those are going to have maybe a harder time. I don't know, because it's more generic. So maybe there's like one company that does this for everyone, but it's less, or that like every company that that has enough resources will do it for themselves because it's too custom tailored to generalize. So those are like two extremes. I don't know. Yeah, that's sort of maybe my take on it. But we're living in interesting times, especially with everything that's going on with like the economy and everything. Next 2 years are definitely going to be interesting. Um, so last thing, recommendations for the audience. It doesn't have to be data science related. If you saw a good Netflix show, feel free to share that. But yeah, what do you recommend people listen to, read, see, whatever?
Netflix show is so I got to see Gayar a couple of weeks ago, and I got COVID there, so I had to basically spend an entire week in my hotel, like in the room of my hotel. So it's a
Oh
week
no.
of hotel food. So if you know if the virus doesn't kill you, hotel food will actually try to. And I watched a movie like a TV series after a while because it was like first time after a while that I had to do nothing and was basically in bed all day. And I watched a series called The Boys. I think
It's
it's on Amazon
wonderful.
Prime. Yeah, and I thought it was well made. I'm not sure if it's like a life changing suggestion for people, but this is a very recent one. If you want other like if you want more like more like significant suggestions of like things that I think you should know. If you like AI, so I am in AI. I mean, I'm in AI well for several reasons, but like, one of the books that influenced me the most in life is a book called Gödel, Escher, and Bach by a guy named Douglas of Hofstadter, which I read when I was a kid,
Oh
and it
wow.
strongly influenced my idea of like studying logic and philosophy of mind and so on and so forth. It's a book that now will sound a bit old to people that kind of like start doing AI right now with transformers and stuff. But it's a fantastic book, and I think it still contains like a lot of thought provoking and like good ideas of how they want to work. So if you're really passionate about AI, not about putting a transformer in production, which is a very useful endeavor, but it's not AI. If you're really serious about what's behind all of this and why we as humanity started this whole AI thing in 1956. I think that's a good book, and it's a book that is gonna stay with you forever. And I know many people, actually approximately my age, that turns out to be where they are in life, partially
Interesting.
because of meeting of starter book when they were like I don't know 15 or something,
Wow.
and then their book kind of changed their life. So these are more serious suggestion, and it's something that I always recommend to people that may discover ML today, but they have no idea who Marvin Minsky is. So yeah, which is very different from my path.
Hmm.
As again, I'm much older and I come from an older AI area.
But that's a
To this one.
hard book to read at 15, so that's impressive in and of itself.
Oh, well, yeah, I think it's a cool book,
Yeah.
and I think even if you at that time I certainly didn't get all
References.
of the
Yeah.
nuances of that, but it inspired me enough to then go deeper and and kind of learn a bit more about logic, about Gödel, and about a bunch of stuff that again right now are not easily associated with ML or AI.
Sure.
I think many people doing ML today have never taken a logic class in their life. But it was AI back then. AI back then was mostly non-monotonic logic, what they're called.
Hmm.
And I think there's an argument to be made that some of that they were not making a good service to ourselves by ignoring dozens of years of very smart people work
Hmm.
about intelligent and reasoning. Surely, deep learning works very well for many things, but I also don't like the idea of betting our entire, future of a field,
Sure.
both applied and theoretical, on one trick,
Yep.
which is backpropagation. So like, I think keeping your mind open is a good thing generally.
Sure.
And so my suggestion is a bit against the zeitgeist, but it hopefully will bring the readers back to a different era, and when things were done in a different way, and I think there's still something there to be cherished and kind of used.
Awesome. Those are awesome recommendations. I second the recommendation for The Boys. I like that series. It is violent. If you don't like violence,
Yep.
then be warned. But yeah, it's very good. Sort of in the spirit, like Gettelescher Bach is at least I'm familiar with the book. I have not read it. My co-founder Guy has been, I think, in the middle of the book for like 6 years or something. So it is a challenging book, but I hear good things. I I guess for me, one book recommendation that I have is I just started reading The Three Body Problem, which is a science fiction book, which is supposed to be, I don't know, some people told me it's a science fiction book for rationalists. So I'm testing that hypothesis by reading it and seeing how I feel. But so far it's fun and it's interesting to me. I don't think I've read books like that were translated but originally written by Chinese authors about like the culture of China in the context of science fiction. So it's interesting in that regard as well. So that's my recommendation for today. And with that, Jacopo, thank you very much for taking the time. It was a pleasure speaking with you. And thank you everyone else for joining. Bye.
Thanks for having me, and thanks everybody to be here. Ciao.
Bye-bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.